Okay, so a brief introduction. Most of you will not know me, so I'm currently the support lead at Calyptia. We are as Austin said, the creators and core maintainers of the Fluent ecosystem. I've been working on engineering and in support a bit over 21 years already. And I joined Calyptia a bit over a year. And I have been having a lot of fun dealing with issues and use cases from some Fortune 10 customers that actually have deployments over 100K servers or nodes. So it's been a pretty nice trip so far. Also on the open source side, I've been working with the documentation and issue triage in the GitHub repo. And I'm also active on Slack along with Pat, Anurag, and some other folks. And from time to time going to Stack Overflow. That's not a huge community in our case, but still there are some interesting questions there. So if you're around, if you have any further questions, you can reach out there directly. My handle will be Lecaros on those places. Okay, so what are we going to talk about today? What we are trying to share with you today? First of all, common architecture patterns for the deployment of Fluent Bit. How to monitor these once you are in production, and a little bit on tuning Fluent Bit for max performance and to avoid known issues. A bit on troubleshooting once you are in production, some tips and tricks from supporting these large deployments, and a couple best practices when deploying in production that we have learned by supporting these large deployments of our users and customers here in Calyptia. So before diving deep into that, a little introduction to Fluent Bit for those that may not know Fluent Bit that well. So Fluent Bit started as a log collector a long time ago, but then we have added metrics and traces. So it is now a full telemetry agent and fully open source, of course. These deployments allow users to have a very high performance. This compared to the very good performance that FluentD has in the past, or still has, but now it's Fluent Bit here around. So it's high performance with millions of messages per second being delivered from point A to point B. But it is not just simple moving data from A to B, right? We also allow the users to filter, to further process the log records, to enrich these, or even to drop data that you don't need in your data backend, data that it's not relevant for your troubleshooting or for your auditing needs. So that's something that is very useful too. So far, this has been deployed over 8 billion times only from the Docker Hub. So we are not counting those where a user, a company may download only once and then download from their internal repository. So this is a very exciting thing to share with you. We know that there is a huge community behind this, and we appreciate all your feedback that you provide through opening tickets and, of course, opening PRs on the public GitHub. A little bit on this 8 billion, we have seen how the Fluent Bit adoption has increased since March 2022. And now we should be already close to the 9 billion downloads. And you can see there that the adopters are big cloud providers and observability providers as well. They use Fluent Bit internally, either directly as the open source solution or by wrapping it in their own telemetry or logs agent. So how does Fluent Bit work in general terms? We have sources from where you're going to grab your data, your logs, your metrics, your traces, and you have at the B part, you have the sinks where you're going to move all your data, and in between, you can transform this data, as I said before. And you can do this from any number of sources and then move this data to, again, any number of destinations or sinks. In between, you have your data saved by providing a mechanism to deal with probably back pressure or when your service is not available. So you can have different configurations to keep your data when that's needed. When you deploy to Kubernetes containers with a single daemon set deployed there, you can grab all the logs, metrics, and traces that you are creating in that particular host. And then you can, of course, start working over that. We have support for Lua and WASM for even more complex processing. You can have your own Lua scripts to enrich your data or to drop your data or do whatever you want with it. And yeah, by using Lua scripts, the flexibility is huge, and we support that. And yeah, we have over hundreds of integrations. So as I was saying, this could be one agent to rule them all. So, and part of these plugins that we have are generic TCP and HTTP inputs and outputs that you can easily connect to your legacy sources of information that only know how to talk TCP or HTTP, or even new destinations that you may need to move your data to. And also, you will have a specific vendor or technology plugins like Splunk, like OpenSearch, Elastic, Azure, Log Analytics, Datadog, Google Chronicle, etc. You have the flexibility to send to any of those with specialized plugins. And of course, we work with common data structures. If you need to, for example, send on gzip format, if you need any other format like Prometheus, OTel, or Avro, or any other format, yeah, we have support for those. And as mentioned before, we are now a full telemetry agent with logs, metrics, and traces, and a lot of filters that will allow you to enrich the data or drop it. Sorry. Okay. Bear with me, please. Okay. So we're gonna now talk about the common architecture patterns that Fluent Bit has been deployed. We have seen this through our experience with users and with customers, and we're gonna talk about two of these more common architecture patterns. The most widely adopted is as a collection agent, where you will have one agent in one node, and this agent will collect the information from all your applications, and also from the operating system, and from whatever source that you may have there. If you also need your the information from your node, like using node exporter, Fluent Bit can also collect that and then send it out to whatever sync that you need to send that information, right? Um, this this agent is the equivalent of a sidecar container on Kubernetes. There's some advantages and disadvantages on using this parent or other. Uh, on this case, you can have all the processing done on this node, and then send that information to your sinks already processed, already enriched, or already filtered out. So this should be a pattern where you will have uh, the processing completely here in the agent, and it will come with the same advantages and disadvantages of having a sidecar, right? So it will consume resources from your pod. So you will notice the resources consumption. If it is consuming a lot of resources, you will notice in the pod performance. And these sidecars could raise against the application pod, right? So if one started before than the other, there could not read all the logs, etc. Some things to keep in mind. Usually it will work fine, but it's something to keep in mind when you start seeing unexpected behaviors, right? And then the other parent will be using as an aggregator. So on this pattern, you will have, again, one agent per node, but the processing that you will do in the node will be minimal. This is a kind of centralized processing where you will have these Fluent Bit agents like forwarders of the data only. So they will collect and immediately, or with a very low processing, send the data to your aggregator. And your aggregator could be one or more instances of Fluent Bit, or even Fluent D if you still have that, where you will do most of the processing, where you will do all the processing if you're not doing any at the node level. And this also presents some advantages. If you need to, for example, change any configuration, you will only change it here, and you don't have to redeploy or restart the agent in all the nodes. So this will allow, by moving your processing to the aggregator, you will have max throughput here at the origin of your data. And of course, the resource utilization will be really low. Fluent Bit is already lightweight compared to Fluent D. For example, the memory usage was previously on Fluent D of about 60 megs, and now is below 1 meg. So only with these improvements and with this pattern, you can maximize the throughput from the origin to your aggregator. And then you can have here all the all the configuration that you require to preserve your data, to further processing, etc. So the actual processing power here in the aggregator will be able to escalate independently, right? If you need further power, you will not have to do any modifications in your source, but you will grow here as desired only in the aggregator side. And this, of course, will require to have more power here, right? It is a balance. If you have deal with performance issues, if you have deal in the past with tuning scenarios, you know that it is a concession game, and where you try to balance it, what you're improving and what you can lose because of that improvement. So it is the same here. The resources are limited, so we have to balance all these variables. And yeah, the single point of configuration here will allow you to do modifications as needed, and to not have to restart or move your configuration at the origin of the data. And of course, again, as Fluent Bit is vendor agnostic or vendor neutral agent, if you decide to change your sync or to add a new one, or even keep sending to different endpoints at the same time, let's say, for example, you will send your debug level logs records to cold storage because you don't need it immediately, but you may need them later. Or if you want to send other live information to any other service live, you only send that information that you require, and you will change only here in the aggregator component of your architecture. Okay, there was a question there, I think. From Francisco Eguiguren. Oh, in your typing, it seems, an answer there.
Yeah, I was just about to send a quick response. He was asking about extensions, but I'll respond directly in the chat.
Okay. Okay, I'm gonna move then to monitoring Fluent Bit in production. So Fluent Bit allows to send logs, metrics, and traces to have an overview, to observe our systems, right? But we also need to observe the observer here, to monitor Fluent Bit, and for that we have exposed some metrics. We exposed these metrics like uptime, and we exposed metrics per plugin instance, about the records process, about the use memory, the bytes process. We publish both, so you will see number of records processed, number of bytes of the records processed. We also provide metrics about the filters, because the filters could add or remove records, and also how much data we have processed in terms of bytes and in terms of records. And we also have metrics about the storage, which will become important as we progress here. We'll see what the storage has to do with this, but those metrics used to be in the past in another HTTP endpoint. Now with the API version 2, all the metrics are in the same endpoint, and you can consume them from one endpoint only. So how can you scrape these metrics? Estimate that over 90% of the users will use Prometheus. So we publish our metrics using JSON and Prometheus formats. You can have both if you, depending on what you want to do with them, right? But for example, for Prometheus, we can scrape the data from a single host or a single pod with a really basic scrape configuration in there, and you will query this path in the server. Fluent Bit exposes these metrics to an HTTP server. The default port is here the 2020, but of course you can change it. You can choose on which network interface you want to publish that, etc. And then you can grab the metrics data from there. And also from Prometheus, you can gather the metrics from all your pods running in your cluster. For these, you will have to make some configuration in both in the Fluent Bit daemon set configuration, which are these annotations that you can see on the screen. And of course, you will also have to configure your Prometheus deployment on that same cluster, like provide the permissions, the relabeling that you may need, etc. This is a well-known pattern to gather information from Fluent Bit. So there are a couple blog posts on the internet if you're interested on configuring this. And also, as Fluent Bit may speak a lot of languages, let's say, Fluent Bit can also write to your Prometheus instance. You can use the output plugin Prometheus Remote Write and send your metrics from your Fluent Bit instances to your server. And of course, you can, as shown on this example, you can add your own labels to that data that you are sending. Okay, so with this metrics in place, once we have already started to watch our metrics of Fluent Bit, there are some patterns that we can look for and see if Fluent Bit is presenting any issues before we receive those calls that we're not expecting from our users, right? So one of the important patterns to look out for will be the back pressure. So what is the back pressure? Basically, we can define this when in certain scenarios, your ingestion capacity is bigger than the throughput that you could have in your output side. So let's say you are able to ingest 50K records per second, but your data endpoint is only capable of receiving 30K per second, or even when your endpoint is down. So what happens here? How can we detect this? And what happens at Fluent Bit side is that as it starts to retrying to send this data to your endpoint, which is not available or not capable of cope with the throughput that you're trying to send, Fluent Bit buffering mechanism will start consuming more resources, of course, because it has to deal with this back pressure in place. So basically, you could see if you are consuming your data from the metrics, something like this. The first The first chart is for input records. So you can barely see at about 6K per second there in the input. And it was similar on the output. But then in the third one, you can see the difference between both, right? You can see that the output has gone very, very low, and the input continues with a good rate of ingestion. So in this case, yeah, we're suffering back pressure uh, from the data endpoint, from the sink where we're sending this information. And yeah, we can deal with this using file system storage mechanism. That's the most recommended. We are going to talk a bit more about that later. And once you see this back pressure in your monitoring chart, you should make some questions to see if you need to actually deal with it, or how to deal with it. It could be that you have peaks of data ingestion, or that uh, the endpoint is down, or how the resources look in your node, in your server where Fluent Bit is running, probably is having a different kind of issues that is not allowing to send the data to your endpoint sink. And another patterns to look out for will be the retries. For this, we also have metrics. Um, you will have in the Fluent Bit metrics the retries per output plugin. And what is a retry? Basically, when you are sending your data to your endpoint, Fluent Bit will try to flush this data to your endpoint, right? And then there could be three answers to this operation. One will be okay, meaning yes, I took this chunk of data, I send it over, and the server replied with an okay, 200, right? Or 201, whatever the server responds. And the other will be an error. It means that for some reason, I send something that is wrong from my side, and the service rejected. And it rejected it because there was something wrong with this data. It could be format, it could be an index issue in your data backend, or any other reason that makes this chunk non-retriable. Okay, so it's an error. I will not retry this. And the third answer could be yes, there was an error while sending the information, but I can retry this. This is, for example, when the endpoint is down, or when the endpoint returns 500 error, or even when the server not responded with a 500, but with a 400, saying that, hey, I'm receiving too much connections at this time, too much data coming my way, so I cannot serve you now. So this will be the three. And in the case of the third one, when I can retry to send this chunk, Fluent Bit will schedule a retry task. So internally, the Fluent Bit engine will ask the scheduler to schedule a retry task, and it will be retried in the future. Okay. And yeah, and the other will be the drop records. These dropped records are counted when I have records that are not longer retriable. This could happen because of these 400 errors, right? Where I send improper data to the endpoint, or when the retries were exhausted. You can tell Fluent Bit, hey, if the endpoint replies with an error which is retriable, then retry 3 times, 5 times, or retry forever, or no retries at all. So in any of these cases, on the retriable that already exhausted the retries, or when in the case of an irrecoverable error, we will count the drop records. And then, yeah, you will have to start looking into the logs, into the Fluent Bit logs, what is going on here. So these are the most common patterns that we have observed. The reason for that are multiple, as mentioned before, that the endpoint is not available, or we made some errors in the formatting, or even in the index creation in our data endpoint. I'm seeing more questions, Justin.
Yeah, there was a quick question on what logging is expected for retries, dropped, etc. And then there was a follow-up question to that was asked before by John. I believe we just covered some of it actually, but for the question, yeah, has the V2 metrics in Prometheus endpoint been tested against Telegraph? John said that he recently tried using it, but got an error about duplicate help statements.
Okay, no, I don't have test that. I think it's a good idea to reach out through GitHub or to Slack, and we can take a look into that. That's interesting. I haven't used that against with Telegraph. Yeah. Oh, the error was from Telegraph, not from John Levox saying. In the chat. Okay.
Yeah, Tom, we'll follow up with you afterwards and see if we can help with that error.
Okay. Okay, so yeah, okay. A little bit on tuning Fluent Bit on this cloud native environment. Before going into that, a brief overview of how Fluent Bit works, right? So we have multiple sources that we can grab data from. Then in the middle is Fluent Bit processing, and then sending to different endpoints. And to do this, Fluent Bit will, instead of just saving the JSON, the most common format out there, instead of saving this data through the processing, through the pipeline, it will use message pack. Message pack is a compression library that we use to, of course, save space, and the one that we use during the whole pipeline. So Fluent Bit will have the ingestion side, the input plugins, then we'll have the filtering, then a buffer, and then it will route the data to the different endpoints. And in the middle, then it will use message pack to save the data. As you can see there, there are savings. These are simple examples of how message pack use less space than JSON. So this is what we use for data serialization inside Fluent Bit. And then once we have this data converted to this format, we will have our chunk files. Sorry, chunks, which are also chunk files if you use the file system storage, but the base structure for this is a chunk. So a chunk will be a group of events that belong to the same tag, right? You will do processing, you will convert it to message pack, and you will put it into the chunk. And if there is any other filter in the pipeline, it will repeat this operation. Will unpack from message pack, will do what it requires to do with this event, and then we'll pack it back into message pack. So the format that Fluent Bit use will be this a chunk with a tag with the records and with metadata as well inside it. So when Fluent Bit is working with this, it will have chunks of 2 megabytes. This is kind of a soft limit. So let's say that from those 2 megs, you have only 15 kilobytes free, but your next event is of 20 kilobytes. So it will save it to the same chunk most probably. So it will move a bit over the limit, but the soft limit for this is of 2 megabytes. This is something hard coded on Fluent Bit, not a configuration parameter yet. And Fluent Bit will process this data and will append to chunk based on this buffer chunk size. This is a configuration setting that the users may change. We have basically two parameters there, the buffer chunk size and also the max size. But these are the units that will tell Fluent Bit how much data at a time it will process. And all this processing is done in memory, even if you have a file system back storage, it will do all the processing in memory. Fluent Bit has this concept of having chunks up and chunks down. So while Fluent Bit is working with a chunk, it will be up, in the state of up. It means it is in memory, right? Not on the disk in case you are using file system storage. And once Fluent Bit is done with that, it will put it down, right? That could not be immediate because Fluent Bit will then pass this instruction to the kernel, and the kernel may decide to do it later on time, but this is how Fluent Bit works and how it treats these chunk structures.
And Lucaros, there's a quick question. If messages are over 2 megabytes, is there any issues with the chunking process?
Okay, yeah, good question. So what will happen is that you will have chunks of over that size. Okay, Fluent Bit will not cut it out. The option where the event or the log event could be cut it out will be, or left out, is if you use skip long lines. Okay, that's a parameter that you may use for that. But if you're not skipping long lines and you have a message over 2 megs, the chunk will grow enough to allocate that log event. And yes, as Ryan says there in the question, yeah, it's a bad pattern, and you should try to troubleshoot that, to know why you're having such big log events. We have seen even funny stuff there. We have seen like full PDF files written to the log file. So yeah, it's something that you need to look into. There's another question of Ennis, I think.
Yeah, I'll grab that one and answer it in
Okay.
the directly. There's another one from Francisco though. So what is the use of using different serialization mechanisms with Fluent Bit pipeline, since it will again be deserialized at the output? Is it to reduce memory usage of Fluent Bit?
Yeah, exactly. As we mentioned before, Fluent Bit was born after the experience with Fluent D, right? Fluent D was written in Ruby and with a bigger footprint on the system. And now, yes, Fluent Bit is a lightweight telemetry agent. So yeah, that's one of the reasons we are using message pack to actually compress the data. Yeah, thanks for that question, Francisco. Okay. So some settings that Fluent Bit exposes to deal with this will be the aforementioned buffer chunk size. It means Fluent Bit will process this amount of data each time for each file. Okay, this thinking that we are using the tail input plugin, this configuration parameters are per file. So per file, Fluent Bit will process this amount of data, this amount defined by buffer chunk size. And the buffer max size, yeah, is the maximum it will have for each file. And if you are not using the file system storage, you can also limit the amount that Fluent Bit is going to consume by using the membuff limit. So it will pause the ingestion if this limit is reached and you are not using the file system storage. And then you have storage limits, mostly at the output side, and also on the input side. But this have been proven more useful in the output. So in the input side, you can improve performance by enabling threaded input plugins. Fluent Bit before this run in the input in the main thread of the application. So of course, if you have parts in there or any other operations, or you have a lot of input instances, yes, you will notice that that the ingestion was not as performant. But now you can mark a input plugin as threaded, and then it will create a different thread or coroutine to process the input instance. And recently, we have introduced processors that will allow to have more filters in the input side. Not only, for example, a parser that you can define on the tail plugin, but you can put there any other filter that you may need, and those will run on this thread. not on the main thread. And in the output side, you have workers. Fluent Bit used to run again it was a different thread, but still only one thread. But now with the workers configuration parameters, you can tell Fluent Bit to open, let's say, 8 different workers for the same output plugin, and they will run on their own thread. And you also have the processors there. I think Anurag talked about this on the previous webinar, but if you are not there, this will allow you to send or further filtering your data but just before sending into different outputs. So this could help you if you were doing rewrite tag or sending from one pipeline to the other for further processing before sending to your data endpoint. So now you can do this at the end of your pipeline, right? So do the common processing from the left to right, and only once you are at the output, you can do further processing. Let's say you only want to send the info log level data to one output. You can filter those out and only send what you require. And in the output, it's the storage limit. This is to deal with the back pressure, right? How much disk or will you use to deal with this? Will you allow losing records, etc.? So this will allow you to say how much you want to use from your system. We know that some users even will not use any disk at all and will only want to have something in memory, right? So you can manage these settings in the output side to limit the storage usage.
So Carlos, we have another quick question there. If you run multiple workers, does that mean that downstream you might get events that are out of sequence?
Okay, good questions. Yeah, well, actually, the sequence of the log events is not guaranteed when, for example, you have retries, right? If you have retries and one new chunk which has new log events, if that one succeeds before the retry of the previous one, they will not be in order. So in general, we do not guarantee the order there, fortunately. Thanks for that question. Okay, and also related to this compacting data on Fluent Bit, if you have multiple filters running in your pipeline for all your pipelines in your configuration, this could degrade the performance because it will be constantly decompressing and compressing again from JSON to message pack. And for these, what we proposed was to use Lua. So instead of having one filter after the other, you will have only one Lua script that will do all the transformations required by your pipeline. We did in conjunction with one of our partners. They did a lot of testing on this. They had amazing images about that, and they proved this, and we did some testing, and yeah, this is the recommendation that we can do now. If you have multiple filters there, it's better to use one Lua script to do all the transformations required. If you missed the previous webinar there, Tiago, our Lua expert, he mentioned this way, and he's also around on this Slack and on GitHub if you have further questions about the use of Lua. And we have this multi-line support, and we have basically two ways of supporting this. One, it is the built-in multi-line parsers. We have a parser for Python, Go, Java, and you can use them right in the tail input plugin. And in the other case, in other scenario, you can use your own custom multi-line parsers. There you will define your multi-line parser regular expressions, right? You will first define the start state, which is actually required, that must be the state name. And you define, yeah, how the first line of a multi-line message will look into this log that we are gathering, right? And then how could look the second one, and so on. These are regular expressions, so you will not go over each line of your multi-line parsers, but you will have to define them to match with the body of it, right? This being open source, you can take a look into the code, how the different multi-line built-in multi-line parsers are defined. And of course, we are there if you need help with it through the community. And long lines, we mentioned that with the previous question. You can skip long lines if for some reason there is no end of line character in your log record. You can skip that if it's too long. And we have also seen one issue called the clubbing issue, where we see that records that are supposed to be or not multi-line are growing immensely, right? We have detected logs over 5 megs, and that was because the regular expression was not correctly defined. We used to recommend the use of rubular.com to test your regular expressions, or even we have seen some users and part of the team asking to AI chat whether or not the regular expression is good, or if it is optimal. So that's something to look into as well. Okay, a little on the troubleshooting in production. These are common things that we see in both the community and some of our customers. So let's say that your data is not flowing, right? Our recommendation is to start simple and then increasing the tooling to find the root cause of why this is not flowing, right? If you start with the Fluent Bit log file, you should have very good clues on what's going on there. Pay, of course, attention to errors, but also look into the warning messages. Fluent Bit will tell you that it could not deliver a chunk of data as a warning because it's retriable, right? But it could be that your endpoint is down, but Fluent Bit is not yet capable of detecting that pattern and act upon it. So you should, look into the warnings, see what they're saying, and see if there is something that you can do to remediate that. And if it's nothing there or nothing is clear there, then we recommend to increase the log level. We know that this could use a lot of disk space, but it works sometimes to increase the log level to debug or to trace and see what's going on in your pipeline. And of course, you have the metrics. Take a look into your dashboard, see if you have drops or retries, etc. I think there's another question there.
Right. Is there anything like Fluent D's secondary so logs aren't lost?
I'm not familiar with Fluent D's secondary. So sorry, I cannot answer that. We can probably follow up later.
Yeah, sounds good. We'll follow up. We'll follow up with you directly, Phil.
Okay. Okay, let's say we're dealing with corrupted and rejected messages. Increasing the debug level, because we have some extra information there from Splunk, Elastic, OpenSearch. You can have the trace error and trace output options, so you will see the request and the response from that service, and you can find there that the error could be because of mapping or indexing issues in your data backend. And the always very useful standard output. Fluent Bit has an output plugin called stdout that will print the messages to your standard output, so you can see what is actually trying to send over. And another common case that we have seen is that the formatting is incorrect. And for this, we recommend first check the source. Check that you didn't change anything in the architecture or that there were no changes in the application. For that, of course, use the standard output plugin and look for changes. For example, on Kubernetes, we have seen lately an increase of these cases where they changed the runtime format. So now it seems that Fluent Bit added some extra data to the log record, but it's actually that the runtime changed, so the format of the logs changed. And if your log events are multi-line, take a look whether or not this is a built, sorry, if this is a built-in parser, if it is a custom, if it is correct, validate your regular expressions, and that will be the recommendations on these cases. A few best practices deploying in production. This is something that we have learned together with users and huge deployments in our customers. Over 100K servers deployed there have shown us a couple of things. If you are not allowed to data loss, use a storage file system. So if your backend is not available or Fluent Bit for any reason cannot send the data, you will have space, literally space, to retry that in the future. So use a bit of your disk to save that records until Fluent Bit can retry or successfully retry that. What happens when there is an error from the endpoint is that it could be retriable or not, right? So this will determine whether or not Fluent Bit will use your storage to save those while it is waiting for the retry, right? If the data is finally not sent, and yeah, Fluent Bit will count that, will say, hey, I had to drop this, I could not send them. For further information, you have to check the log files, right? But it will delete these records that are not retriable or that were retried to the limit configured. And that is the retry logic that enters into the game. This retry logic by default will retry only once, but you can tell to either retry without limits or a fixed number greater to one, of course, a fixed number of retries, and these retries will be managed by the scheduler, not directly by the Fluent Bit engine. And in the ingestion side, start simple, then specialize, right? If you deploy Fluent Bit as a daemon set, it will grab all your logs, and then you will have to start learning from your logs, right? Know your logs, know how the different applications that are sending data to your pipelines, or that they're consuming through your pipelines, learn how is their data, if it is a structure, or what will be the regular expression that will actually parse that data that comes in your log events. And again, check your regular expressions. Yeah, we have noticed that regular expression can have a great impact, whether they are greedy or not. They can impact in the processing. We have done changes there that somehow help to deal with this, but by removing the processing from the main thread. But yeah, you should always check your regular expressions. Okay, I think that's from me now.